All right, let's get right into it. Got a big operating systems exam breathing down your neck? Or maybe you just want to finally understand what people mean when they talk about kernels and processes. Well, you've come to the right place. We are about to pull back the curtain on the most important piece of software you own. So let me start by asking you a question. Just think for a second. Of all the apps, all the programs, all the games you use, which one is the absolute most critical? I'll give you a hint. It's not your web browser. It's not your favorite social media app. Nope. It's something that works so perfectly, so silently in the background, you probably forget it's even there. And the answer is the operating system, or OS for short. Now, the official textbook definition says it's an interface between a user and the computer hardware. Which is true, but kind of dry, right? A better way to think about it is like a translator. You click an icon, and the OS translates that simple action into complex instructions that the physical hardware can actually understand and execute. And this diagram, it shows that idea perfectly. You've got your applications on top, the hardware at the bottom, and the OS is that crucial bridge in the middle. Now, for your exam, here is the analogy to remember. The OS is like the government of your computer. It doesn't write your emails itself, but it creates the rules, the roads, the entire infrastructure that allows all your other programs to run. It is the ultimate unseen manager. So here's our game plan for this study session. We'll lock down what an OS is, then we'll dig into its main job as a manager, look at its support staff, check out the 2 main ways to build one, and finally wrap it all up with why any of this actually matters. Let's do it! All right, first section. Think of the operating system as the invisible boss, that essential layer of control that makes everything on your machine just work. When you boil it all down, the OS is constantly trying to do 2 main things at once. First, make your life easy. That's the whole reason you can just click an icon and a program opens. Convenience. But second, it has to be incredibly efficient. It's constantly juggling the computer's limited resources, its power, its memory, to make sure nothing goes to waste. It's kind of like a master chef trying to cook you a 5-star meal without wasting a single ingredient. It's a really tough balancing act. Okay, now we're getting to the absolute heart of it. If the OS is the big boss, then it runs 3 super important departments. If you can understand these 3, you're going to ace any question on this topic. I promise. First up, we've got the Task Management Department, or as it's officially called, Process Management. So, what's a process? It's just a fancy word for any program that's currently running. Right now, if you're watching this while you have a web browser open and maybe some music playing in the background, boom, you've got at least 3 processes running, and the OS is the manager in charge of all of them. And this is where things get really cool. The OS is constantly switching these processes between different states. A process can be running, which means it's actively using the computer's brain, the CPU. It can be ready, which is like waiting in line, totally prepared to go. Or it could be blocked, meaning it's waiting for something else to happen, like for a file to download. The OS acts like a super fast traffic cop, directing all these processes from one state to another, thousands of times a second. It happens so fast that it creates this amazing illusion that your computer's doing a million things at once, even though a CPU core can technically only do one thing at a time. So to wrap up this department, its job is to start processes, stop them, pause them, and restart them. It also has to prevent a really weird situation called a deadlock. That's when 2 programs get stuck because each one is waiting for the other to do something first. It's like 2 people on the phone where both are saying, you hang up first, no, you hang up first. They'd be stuck forever. The OS has to be the one to step in and say, okay, that's enough, and break the stalemate. All right, on to department number 2, memory management. The best way to think about this is to imagine your computer's RAM, its active memory, as a small desk. Every single program you open needs to spread its papers out on that desk in order to work. The OS then has to be a master organizer of this desk space. So what happens when that desk gets too crowded with too many open programs? Well, the OS has this really clever trick called swapping. It'll take a program you haven't used in a few minutes, carefully pack all its papers into a box, and store that box in a closet, which is your hard drive. This frees up desk space for the program you're using right now. Then, when you click back to that older program, the OS quickly grabs the box from the closet and unpacks it back onto the desk. That little delay you sometimes feel, that's swapping in action. So this department is basically the ultimate office manager. It keeps a constant list of who's using which part of the desk, it decides who gets space when it opens up, and it cleans everything up after a program is closed. It's all about making the most of that very limited, very valuable workspace. And that brings us to our third and final major department, file management. So if your computer's RAM is the desk, then your hard drive or SSD is the massive filing cabinet in the corner of the room. It's where you store absolutely everything for the long term. Now, can you imagine trying to find one specific document in a giant filing cabinet that has no folders, no labels, just a giant pile of paper? It would be a complete nightmare, right? Well, that's what your hard drive would be like without the OS. The OS is the one that creates that neat structure of files and folders and subfolders that keeps our entire digital lives from descending into chaos. It's the ultimate librarian. So you got it. This department handles everything to do with that filing cabinet, creating new files, deleting old ones, organizing folders, and maybe most importantly, keeping a detailed map of exactly where every single piece of information is physically stored on the drive so it can be found instantly. Okay, so those are the three big departments, but no manager can do it all alone. They need a great support staff. So let's quickly look at the other essential systems that help the whole operation run smoothly. These are the unsung heroes. First, you've got input/output management, or I/O. Think of this as the company mailroom. It handles all communication with the outside world, your keyboard, your mouse, the printer, the monitor. It makes sure that when you press the A key, the letter A actually appears on screen. Then you have the security manager. This is the security guard at the front door of the building. It checks the ID of every single program that wants to access a file or a piece of hardware, making sure it has permission. This is what keeps viruses and malware from taking over your system. Okay, we've hammered out what the OS does. Let's switch gears for a minute and talk about how it's actually built. Because for your exam, you'll probably need to know the two main blueprints, or architectures, for an operating system. So there are basically two schools of thought here. On the left, you see the monolithic kernel. The best way to think of this is like a giant all-in-one Swiss Army knife. Every important service, process management, memory management, file management, it's all packed together into one big single program. On the right, you have the microkernel. This is more like a toolbox full of very specific individual tools. The main kernel is tiny, and most of the other services run as separate programs. All right, you might want to screenshot this slide because this is your perfect exam cheat sheet. The monolithic design, the Swiss Army knife, is super fast because all the tools are right there ready to go. But it's risky. If one little part breaks, the entire thing can become useless. The whole system can crash. The microkernel, or the toolbox, is much more stable. If one tool breaks, you can just fix or replace that one tool without affecting the others. The downside? All that communication between the separate tools can slow the whole system down a bit. So it's that classic trade-off. Do you want raw speed, or do you want rock-solid stability? Okay, let's bring it all home. We've gone through all the parts, all the concepts. So what's the final exam question? The one big idea you need to walk away with: why does any of this matter? It all comes back to that first analogy we talked about. The OS is like a government. It doesn't do the work for you, but it creates and maintains the environment that makes all the work possible. Without the OS managing processes, memory, files, and security, your powerful computer would just be a very, very expensive hunk of metal and plastic, a paperweight. It's the invisible foundation that our entire digital world is built on. And that's what's so fascinating. The job of the OS has always been to manage complexity. Today, that means managing tasks and files on a single computer. But what about tomorrow? What happens when your car, your fridge, your thermostat, and your watch all have their own complex operating systems that need to talk to each other? What new, crazy things will the OS of the future have to manage? That's a huge question, and it's one that the next generation of engineers, and hey, maybe even some of you watching right now, are going to have to answer. Thanks for joining me.